we have given two functions f and g, and we have to find their compositions. F of g, g of f of f, and g of g. So first we have f of g. Let me write this. We have f of g and of x. So first function is f. So we just copy function f, and we have to find f of g of x. F of, and we just replace g of x by formula of this function is cosine of x. We have, so this is equal. Now we just going to f function. The formula of f function is 2 minus square root of x. So we just copy 2 minus, we copy root sign, and for x we have to put whatever we have in parentheses. So we have cosine of x. And this is our composition function f of g. Now we have to find the domain of our f of g function. So at the beginning we should find the domain f and g function. The domain of f function, let's see what we have here. We have 2 minus square root of x. We know that whatever is under square root must be greater than or equals 0. So let me draw x-axis. We have 0. We have to find value x greater than or equals 0. So because we have x greater than or equals, it means 0 belongs to our interval, and we are going to right side because value we have to find greater than 0. So it will be interval from 0 to positive infinity. So the domain of our f function will be x belongs to interval from 0 to positive infinity. Now we have to find the domain g function. We have cosine of x. The domain of cosine is all real numbers. So we can write r. So we have domain f function and g function. Now we can find the domain of f of g function. We have 2 minus square root of cosine of x. Again, whatever is under square root must be greater or equals 0. So we have to solve this inequality. To solve this inequality, we will draw the cosine wave. We need x and y plane. Important point, because we know that value cosine we have between -1 and 1, and the roots for cosine are pi over 2 and 3 over 2 pi, and so on. We have negative pi over 2. What else? The value cosine for 0 is 1, and for pi is -1. So we can draw our cosine wave. And we know that cosine repeats every 2 pi. We see from negative pi over 2 to 3 pi over 2 is exactly 2 pi. This cosine repeats every 2 pi. Now we have to find the value cosine of x greater than or equal 0. Greater value is whatever is above x-axis. This part is above. And greater than or equals, so it means negative pi over 2, and pi over 2 belongs to this interval, and this will be 2 pi, 5 over 2 pi. Again, this part repeats. So we can write that cosine of x is greater than or equals 0 for x belongs to interval closed on both sides, because we have greater than or equals, from negative pi over 2, and because this cosine repeats every 2 pi, I have to add plus 2 times k. Pi k is integer, and from negative pi over 2 to pi over 2, and again I have to add 2k pi, close interval. So this is our domain for our f of g function. And what else? We have to look for, because we have f of g of x, we have to check the g function. The domain of g function was all real numbers. The domain of f of g, we got this interval. It means when we put together these two domains, the domain of our f of g function will be this interval. So now we have to go to function g of f at x. The g we just copy, and we have g in parentheses. We will have f of x. This is equal. Now we have to replace f of x by formula of our f of x function is 2 minus square root of x. So we have g of 2 minus square root of x. This is equal. Now we have to go to our g function. Our g function is cosine of x, and x we have to replace by whatever we have here in parentheses. So we have cosine of 2 minus square root of x. This is our function g of f. Now we have to find the domain. So it means we have to check the domain, because we have g of x function. So the domain of f function was interval from 0 to positive infinity, and we have here cosine 2 minus square root of x. We can calculate cosine for every real number, and here we have square root. Square root must be greater than or equals 0. So when we put together x greater than or equals 0, and the domain of f function is interval from 0 close on the left side to positive infinity, we see that this is the same interval. So the domain of our g of f function will be interval from 0 to positive infinity closed on the left side. Now we have to find the composition of f at x. This is equal. We copy the first function f, and we have f of x First, we will replace f of x by formula of our f function. So we will put 2 minus square root of x. So we have f of 2 minus square root of x. This is equal. Now, because we have at the beginning f again, so now again we are going to f function and we have to replace x by whatever we have in parentheses here. So will be 2, we just copy, minus square root of this whole expression, 2 minus square root of x. This is my f of f function. And now we have to find the domain. First, like before, we check our f function. The domain of our f function is interval from 0 to positive infinity. And we have to find the domain of this expression. Because we have square root, it means whatever is under square root, in our case 2 minus square root of x, must be greater than or equal 0, and we have one more square root from x, so x must be greater than or equal 0, and from our f function domain we have interval from 0 to positive infinity. Let me put this here. X belongs to interval from 0 to positive infinity. We have to put together these three solutions. So first we have to solve this inequality. We have 2 is greater than or equals, I will move negative square root of x to the right side, so it will be square root of x. To reduce the square root, I will take to second power both sides, so it will be 4 is greater than or equals x. So I can rewrite this is x is less than or equals 4. So now we have to put together these three intervals. Let me draw x axis. We have 0, we have 4, and because we have x is less than or equals 4, it means 4 belongs, and x is greater than or equals 0, so 0 belongs. So let me draw. We have x is less than or equals 4, less, so value less we have on the left side. Now we have x is greater than or equals 0, and this interval is exactly the same which I just draw, from 0 to positive infinity. Well, so when we put together these three intervals, we see that solution will be in this interval from 0 to 4. So this is our domain for our f of f function. X belongs to interval from 0 to 4, close on both sides. Now we have to find g of g function, g of g at x. This is equal, g we just copy, and we have g of x. This is equal, first function I just copy, g of x I will replace by given formula. This is cosine x. So now again we have g function, so it means we have to replace our x in our g function. The cosine we just copy, and x we have to replace by cosine x. So we have cosine of cosine x. This is our g of g function. So now we have to find the domain. We have g of x, so we have to check the domain of g function. The domain of g function is all real numbers And what we have here, we have cosine again. And cosine, the domain of cosine is all real numbers. We can calculate cosine for all real numbers. So the domain of our g of g function will be all real numbers.